Hi guys, welcome to our very first flipped video. Even though we're watching this video in class, this is what we will expect and will come to learn as our new norm for watching these videos at home. So today, even though Miss Sandwich, I am going to be in the room with you and showing you how to take notes and what it means to be good listeners, you're going to listen to my voice on the computer because this is how I want you guys to start getting the hang of listening to the mini lessons. So first thing what we're going to do is we're going to write our title for our notes, which is rational numbers. And next to rational numbers, I would like you to put today's date. Underneath the title, I would like you to write objective, just like it is here. And our objective for today is I will be able to identify and plot a rational number on a number line. Our first definition is rational number. Now there's multiple parts to a rational number, the definition of rational number. And the first part is any number that can be written as a fraction without a denominator of 0. So any number that can be written as a fraction without a denominator of 0. So 0 could be the numerator, but it cannot be the denominator. Another way to think about it is a rational number is any number that can be written as a decimal that either terminates, which means ends, or repeats. So the decimal might end, or it could repeat and go on forever and ever and ever. Now, repeating decimals can be terminating decimals as well. Maybe they repeat for just a little bit, like 1, 2, 1, 2. That's a repeating pattern, but it doesn't go on forever. A popular repeating decimal is 0.33333, go on forever, which is 1/3 as a fraction. So we know that that's a rational number. Another point to rational numbers is that it can be either positive or negative. Both positive or negative numbers are rational numbers. Positive or negative numbers that can be written as a fraction, that is. Let's clarify that. And last but not least, all of these numbers can be placed on a number line. They can be placed exactly at a point at a number line. So here are some examples that we're going to write down. So our first example is 3/4. And 3/4 is a rational number because, well, it's already a fraction. We already know. And we also know because we can put it right there. It's on the number line. It's right there. We can point to it. We can plot it. So on your notes, I would like you to write and actually draw this number line with the point to really set it in that a rational number has to be a point on a number line. Another example is the number 5. Now the number 5 is a whole number, but it can be written as a fraction, 5/1. So because it can be written as a fraction and plotted on a number line, it is a rational number. -2 is also a rational number because, like we said before, rational numbers are positive or negative. So -2 can be written as -2/1. -2/1 is a fraction, and -2 can be plotted on a number line. 0.4 is also a rational number for 2 reasons. The first reason is because the decimal is terminating, or it ends, and you can write 4/10 as a fraction, 4/10. And you can plot both of it either way on a number line. And my last example is a repeating decimal, 0.033333, going on forever. That line above it means it goes on forever. And we know that that's a rational number because, first reason, it's a repeating decimal. And the second reason, because you can write 0.0.33333 going forever as 1/3. And you can plot 1/3 on a number line. To help us understand rational numbers a little bit more, we're going to have a couple non-examples, or examples that are not rational numbers. Everyone has heard of pi, I hope. Not the pie that we eat, but the pie in math. And pi, as we know, or most of you probably know, that it starts off with 3.14159, and it goes on forever and ever and ever. This picture right here, this black picture, is just part of the number pi. It just goes on forever. The picture right next to it is the square root of 2. The square root of 2. And you can't really see it, but all of those little numbers back there make up the first 10,000 decimals of the square root of 2. It means it goes on forever, and it's not repeating. Both pi and the square root of 2 go on forever, and they do not repeat. There's no pattern. So those are not examples of rational numbers. So now, at the bottom of your notes, I want you to draw a line and write summary, and write a couple sentences summarizing what we just went over on these notes. And these will hopefully be able to help you when we do the activity later. Thank you all for listening, and I will see you in class.